Have you ever wondered why no two individuals have the same fingerprints, even identical twins? A fascinating question, isn't it? Well, that's the enigma of fingerprints, those intricate patterns of ridges and valleys on our fingertips. They've been intriguing scientists and investigators for centuries, serving as irreplaceable tools in personal identification, criminal investigations, and the biometric industry. The general consensus is that each person's fingerprints are utterly unique, as distinct as the individual themselves. That's why you often see detectives dusting for prints at crime scenes in movies, or why you use your fingerprint to unlock your phone. It's this belief in their uniqueness that has made fingerprints such an integral part of our lives. But have you ever stopped to question why? What makes every single fingerprint so different? Well, we're about to embark on an intriguing journey that explores these very questions, so let's delve into the world of fingerprints and understand what makes them unique. Fingerprints, those fascinating patterns on our fingertips, have intrigued scientists for centuries. Let's delve into the science behind fingerprints. They begin to form in the womb around the 10th week of pregnancy. This process, known as dermatoglyphics, is influenced by a combination of genetic and environmental factors. The basic shape and pattern of our fingerprints are determined by our genes. These patterns, classified as arches, loops, or whorls, are consistent among all humans. However, the intricate details that make each fingerprint unique are shaped by environmental factors. But what exactly are these environmental factors? Well, they're the conditions in the womb, such as blood pressure, position in the womb, and the flow of amniotic fluid. These factors can influence the development of the fetus's skin, including the ridges on their fingertips. These ridges are the result of stresses experienced by the developing skin. As the fetal skin stretches and compresses, it forms complex patterns of ridges and valleys unique to each individual. Even identical twins who share the same genetic makeup have different fingerprints due to these varying conditions in the womb. It's important to note that once these fingerprints are formed, they remain the same throughout our lives. Despite growth and aging, the patterns on our fingers enlarge but do not change, making them a reliable marker of individual identity. Interestingly, our fingerprints also serve a purpose beyond identification. The ridges enhance our sense of touch and improve grip, enabling us to interact with our surroundings effectively. So here's a fun fact. The same ridges that help us pick up a pencil or hold a hand also ensure that we are undeniably ourselves. Our fingerprints are a testament to our individuality, a signature of our existence etched right into our skin. So while our genes provide a blueprint, it's the unpredictable conditions in the womb that lend our fingerprints their final unique form. Now that we understand how fingerprints form, let's explore their uniqueness. The concept of uniqueness in fingerprints arises from the distinct pattern of ridges and valleys on the surface of our fingertips. These patterns, also known as minutiae, are formed during the fetal development stage and remain unchanged throughout our lives. There are numerous types of minutiae, including bifurcations where one ridge splits into two, and ridge endings where a ridge abruptly ends. The configuration, number, and relative location of these minutiae are incredibly diverse, making each person's set of fingerprints unique to them. But what are the odds of two individuals having the same fingerprints? Well, to put it into perspective, the probability is staggeringly low. Statistically speaking, it's estimated to be around 1 in 64 billion. That's more than 8 times the current global population. This incredibly low probability arises from the sheer number of minutiae, typically around 150 per fingerprint, and the near infinite ways these minutiae can be arranged. This randomness in arrangement is influenced by a multitude of factors, including pressure in the womb, blood flow, and even the position of the fetus. To further emphasize the uniqueness of fingerprints, consider the case of identical twins. While they share the same genetic makeup, their fingerprints are distinct. This is because, as we've discussed, the formation of fingerprints is not solely determined by DNA, but also influenced by environmental factors during fetal development. So, in essence, your fingerprints are as unique as you are, serving as a biometric signature that you leave behind on everything you touch. Given the sheer number of minutiae and the randomness of their arrangement, it's almost impossible for two individuals to share the same fingerprints. But what about identical twins? They share the same DNA, so do they share the same fingerprints? Well, let's delve into this fascinating subject a bit. Identical twins, also known as monozygotic twins, come from a single fertilized egg that splits into two. Because of this, they end up sharing the exact same genetic material. So it's logical to think that they might also share the same fingerprints, right? Well, not exactly. While it's true that the basic patterns of our fingerprints are coded in our genes, it's important to remember that our fingerprints aren't just a product of our genes. There's another player in this game, the environment. And no, we're not talking about the world outside, but rather the conditions within the womb. Fingerprints are a reliable tool for identification, but are they foolproof? That's the question we're going to tackle in this section. Fingerprints have long been used as a primary method of identification in criminal investigations and security checks. Their unique patterns, formed by the friction ridges on our fingers, are believed to be distinct for every individual, making them a seemingly foolproof tool for identifying a person. However, as is often the case in science, there are exceptions. For instance, there are rare cases of individuals with fingerprint anomalies where the usual whorls, loops, and arches that make up a fingerprint are absent or significantly altered. These anomalies can be due to a number of factors, such as genetic conditions or environmental influences during development. An example of this is a condition known as adermatoglyphia, also known as immigration-delayed disease, where individuals are born without fingerprints. This is incredibly rare, but it does exist. Now, even if the fingerprints are present and well-formed, there could be potential errors in fingerprint analysis. Human error, poor quality prints, or even sophisticated forgery can lead to false identifications. For instance, in 2004, an American lawyer was wrongly linked to a terrorist attack in Spain purely based on a partial fingerprint match. The lawyer was later exonerated, but the incident served as a reminder that fingerprint analysis, while highly reliable, is not perfect. Furthermore, the science of fingerprint identification is based on two premises: that no two individuals can have identical fingerprints, and that an individual's fingerprints remain unchanged during their lifetime. While the latter is generally accepted, the former is a subject of ongoing debate, especially with the case of identical twins. So what does all this mean? It means that while fingerprints are an extremely useful tool for identification, they are not infallible. They have their limitations and exceptions, and it's important to remember that they should be used in conjunction with other forms of evidence in critical situations. While fingerprints provide a highly accurate means of identification, they are not infallible, reminding us that in nature, there are always exceptions to the rule. So, we've journeyed through the fascinating world of fingerprints, exploring their formation, uniqueness, and reliability. We've learned that fingerprints are formed while we're still in the womb and are influenced by both genetic and environmental factors. This leads to an intricate pattern that is virtually unique to each individual. Even identical twins, who share the same DNA, have different fingerprints due to the environmental factors at play during their development. This uniqueness makes fingerprints an incredibly reliable tool for personal identification. However, we also explored exceptions and anomalies, such as individuals born with featureless fingerprints, which reminds us that nature is full of surprises. In essence, fingerprints are a testament to our individuality, serving as a biological signature that sets us apart from the rest of humanity. While the chances of two individuals sharing the same fingerprints are astronomically low, in science one can never say never. So the next time you look at your fingertips, remember, you're looking at a unique piece of biological art.